Before we start match problem 3, I need to fix a couple of typos that I made here. This should be an investment of $10,000, which we want to grow to $15,000. If it's invested at 9% interest rate, compounded continuously. So in this case, we have to use some algebra techniques in order to determine the length of time. So what we're interested in is how long. So the unknown that we're trying to solve for is t. So we want this amount to grow to $15,000. We're starting off with an initial investment of $10,000, and we have an interest rate of 9%. So the first thing we can do is divide both sides by 10,000 to give us 1.5 equals e to the 0.09 times t. So our next step then is always to get rid of this exponential expression. We can't immediately solve this since t is in the exponent of this exponential expression. So what we'll do is take the natural log of both sides of this function. So the left-hand side will become the natural log of 1.5. On the right-hand side, there's a property of logarithms that lets this exponent drop down as a factor in front of that logarithm statement. So this would become 0.09t times the natural log of e. So even though this sort of looks similar to the power rule that we established for derivatives, this isn't a calculus step to get from here to here. It's just an algebra step. Properties of logarithms say if we take the log of this some base raised to a power, we can rewrite that by bringing that power down in front as a factor. Hopefully we also know that the natural log of e is always just going to be 1. So that cancels out, leaving us with the natural log of 1.5 equals 0.09 times t. So to solve for t, we'll just divide both sides by 0.09, which will give us the natural log of 1.5 divided by 0.09. So for a theoretical problem, this is our exact answer. From here, the best we can come up with is an approximate. But since we're dealing with an application problem, we do want that approximate. We don't want to tell someone to invest money for the natural log of 1.5 divided by 0.09 years. We want to come up with an approximate decimal answer. So to evaluate this, we can use the natural log key. So we're going to take the natural log of 1.5, close that set of parentheses, and then divide by 0.09, which is going to give us about 4.51 years. So in this case, we could say that t is approximately 4.51 years. So after a little over 4.5 years, that initial investment of $10,000 will have grown to $15,000.